One variation of this is a natural monopoly. So natural monopoly is one where there's some barrier to entry that makes it so that one firm is going to dominate this market. So like a utility company would be an example, where generally you're going to have really high fixed costs, and one firm basically is going to produce for the entire market because you're going to have this spreading effect happening throughout the entire range of demand. So for this whole entire market, this entire demand curve, ATC is still falling. So as opposed to our normal case where ATC is rising over this range, we haven't gotten to the rising part over this entire range of demand. So maybe if we kept going, if we try to get this utility company large enough, probably eventually we can get this ATC to rise, but over the relevant range of output, this entire market, the entire town or whatever it is, ATC is falling. So we set up this huge fixed cost infrastructure, and adding one more unit of output, one more customer, is very low marginal cost. Right? The cost is mainly that fixed cost, or think about like a cable company or something. So all we're going to do is keep spreading out those fixed costs, and so our average cost keeps declining, which means if we get really big, there's no way another firm can come in and beat us on cost. Right? We've taken advantage of these economies of scale and lowered our average cost, and so we have this natural barrier to entry, which is why it's a natural monopoly. So main difference is that ATC is falling over the whole range, and marginal cost would have to be below it, because if marginal cost ever crossed, ATC would be rising. So we just draw marginal cost below ATC over this whole range, not worry about what might happen later on. So this is what it's going to look like. And then once we have this, we're just going to profit maximize just like any other firm. So marginal revenue equals marginal cost is here. Go up to your demand curve, get the price, and we have this profit. Price in ATC gives you your profit, and so that's what a profit maximizing natural monopoly would look like, which means this is deadweight loss, because for these extra units we still have marginal benefit, willingness to pay above marginal cost, and so we've lost all that surplus by profit maximizing and producing less. The efficient point would be out here. Notice that if we produce at this efficient point, so suppose a government's going to regulate this firm, this utility company for example, and say you need to produce at the efficient amount, assuming they even knew what that was, there's no way this firm can make money here, because this is MC is always going to be below ATC, which means price is going to be below ATC, which means that's a loss. Right? So if this firm is going to try to be efficient, it will have a loss. Right? It's going to produce the efficient point, set that price, that's the efficient price, but ATC is going to be above it, so that's your loss, and then times quantity would be your loss. So if the government, for example, wanted to make this firm efficient, it would have to somehow subsidize the loss. The other possibility is maybe to make it break even. Again, assuming we had that cost information, which is in the real world is going to be a problem, but that would be your break-even point. So we're going to set price equal to ATC, and this firm will then break even, or maybe you can let it go slightly above break even and make an economic profit. So sometimes you'll see a simplified version of monopoly where instead of having the rising marginal cost and the normal U-shaped ATC curve, what we did here was just assume constant marginal cost, so which we really assumed with our natural monopoly as well. But here we made it even simpler, because we just said this is equal to ATC, which what that means is that we're assuming there's no fixed cost. So again, not realistic, but this gives you a very simple monopoly graph. And sometimes you'll see it just to keep the graph simple, but what we're going to use this for is just to show price discrimination, because it makes the graph a little easier. So if there's no fixed cost, then the only cost is variable cost. Right? To produce one more unit, the only thing we have is variable cost, which means the average is just that same cost. So the average is just whatever that extra variable cost is. So then that equals your ATC. So if we're just going to have an ordinary single price monopoly just to set one price, well, I'm still going to set marginal revenue equal to marginal cost, go up to my demand curve, and I'm just going to make this profit. I'd have this deadweight loss. But the reason I wanted to use this particular type of monopoly is because we're now going to change that assumption of having single price, and this monopoly is going to price discriminate and set some different prices. So first of all, we have deadweight loss over here, we have consumer surplus over here, but now we're going to figure out a way to charge some different prices. So if I have to set one price, that's the best price. So now, first of all, I took out my marginal revenue curve because once I'm not a single price monopolist, that's no longer going to apply, because that's, if I'm going to set one price, then I have to look at, okay, I have that price effect. I'm going to drop all the prices on all my early units, so I'd have that normal marginal revenue curve. Once I start price discriminating, that no longer applies. So it might look different, but we're not going to try to actually show the curve. We're just going to show what's the effect of start setting some different prices. So let's say, I have this whole range here where people are willing to pay more than P1. I'd like to figure out a way to sell to them. So, an airline, for example, is very good at price discriminating. So I want to have a higher price of this out, but I'm going to figure out a way to segment this market where some people with that higher willingness to pay, business class or something, although we should assume it's the exact same, thing that we're selling. So a better example would be if two people bought the same exact seat at different times, week before, a month before, you might pay different prices, or if one stays over the weekend, you pay a different price. So airlines have lots of different strategies like that in order to price discriminate. So somehow we're price discriminating, and I'm going to set a higher price while still selling, to some people at the price of P1. So if I can pull that off, then I can now have two different prices. So now I have a price of P2. So the first Q2 people on this demand curve, if we assume it's like one person per quantity, had this willingness to pay. So they're still willing to pay P2. If I can figure out a way to sell to these people, without them paying P1, then I'm going to do that. So now I set this price at P1. So what used to be consumer surplus is now profit, because for these first few units, I'm now selling them at P2 rather than P1, and I still have this average cost for all these units. So I added this to my profit, right? So I now have this much profit for these first Q2 units, and then I'm going to set another price for the next, units up to Q1. I'm going to sell those units at P1. My average cost is here, so I'm making that much profit for that quantity. So there were still some people who were willing to pay even more than P2, and that's why they're left with some consumer surplus. There were some people over here who ended up paying P1, were willing to pay more. They're paying P1, so they still have some consumer surplus. But this firm was able to cut into this consumer surplus and turn it into profit by price discriminating. So we still have this deadweight loss over here. Let's add one other price to the high end here, and this is still green is profit, blue is consumer surplus, this is deadweight loss over here. So we just did the same thing. I'm just going to add an even higher price and try to carve out a little more consumer surplus for myself here. And so now I'm selling the first Q3 units at P3, and now this is going to be my profit on those units, so I'm able to get some of that consumer surplus. Still have those up at this high range. Someone's still willing to pay more than P3, so they're left with some surplus. The next are paying P2. I'm getting that much profit on these units. They have a little bit of consumer surplus there, and then still, consumer surplus here. I still have some deadweight loss. So I'll show one more, because if I can figure out how to do it on the low end, past Q1 and below P1, I can start carving into that deadweight loss. So let's just do one more. I can figure out, okay, at the low end, bring in a coupon or something, and you can pay P4. Now those sales I wasn't even making before, that was deadweight loss, but now I'm going to sell some more at P4, because remember, the whole idea is I wasn't willing to drop the price if I had to drop the price on everything, but now I've figured out a way to drop the price just on these units, and then I'm willing to do that. So again, I've added more to my profit, I've reduced deadweight loss, I've created a little consumer surplus over here. But you can imagine if I kept carving this up, um, the theoretical extreme would be to sell every unit at exactly what people are willing to pay for it, which means there's no more consumer surplus. I've extracted all the consumer surplus, and I'm also efficient because I figured out a way to keep going. As long as someone was willing to pay more than my marginal cost of production, it would be efficient for me to do that. I wasn't willing to do it before if I had to drop the price on all my units, but now I just have to drop the price on every single unit without dropping the price on other ones. I will go all the way to efficient point, no deadweight loss, but it's all monopoly profit, no consumer surplus in that case.